All right, we are back to talk about our next special segment, and this one is the perpendicular bisector. Perpendicular bisectors, well, that's its most important property. It has to be perpendicular and bisect a segment. A perpendicular bisector is perpendicular and bisects another segment. So in this picture, the blue segment is the perpendicular bisector of AB. That means it forms a right angle with AB, and it also cuts AB exactly in half, goes through the midpoint. Another property of the perpendicular bisector is that any point on the perpendicular bisector will be equidistant to those endpoints A and B, which means it could form an isosceles triangle. Remember, in an isosceles triangle, the legs are congruent. So any point on the perpendicular bisector is equidistant to the endpoints of the segment it bisected. In this case, segment PA would be equal to segment PB. It does not have to come from the vertex of a triangle. If you notice, I'm going to put the letters A and B back on there. That blue line, just like before, is the perpendicular bisector of segment AB. It is perpendicular to AB, and it bisects AB. It does not have to come from the vertex. It will come from the vertex if it's an isosceles triangle, but that's the only time. It does not have to come from the vertex. But again, any point on that perpendicular bisector is equidistant to A and B. Since there's three segments in a triangle, we could have, or three sides, we could have three perpendicular bisectors. The point where they all come together, so the point of concurrency, which is where they all meet, concurrency, where they intersect, is called the circumcenter. The circumcenter, that point where they all intersect, is equidistant to the three vertices. So those three purple lines are all congruent. It's the center of the circle drawn around the triangle. So if we drew a circle around the triangle, that circumcenter is the center of that triangle. So it's equidistant to the three vertices. We're not going to do a whole lot with that, but it does come up once in a while. Okay, let's see what we have here. We're asked to find x and y. Well, we have two expressions that use y. This is a perpendicular bisector, so those segments are congruent. ED is equal to DC, so 3y plus 10 is equal to 4y minus 20. That's y, that's 30. We've got y. The perpendicular bisector, AD, is perpendicular. So we also know that it forms a right angle, or that 7x plus 13 has to equal 90 degrees. So 7x plus 13 equals 90. We're going to subtract our 13, and x equals 11. AD is a perpendicular bisector. It is perpendicular and it bisected. In our second problem here, we're using our knowledge that any point on the perpendicular bisector is equal distance to those endpoints, which really just means we have an isosceles triangle and the 3x plus 14 is equal to the 5x. And we can solve for x from there. And that's it. Perpendicular bisector. It is perpendicular and bisects a segment, in this case, a side of a triangle. Every point on the perpendicular bisector is equal distance to the endpoints. Think about it. If it's bisecting, it has to be equal distance to the endpoints. And we also have the idea of a circumcenter where they all meet. And that circumcenter is equal distance to all three vertices. All right. That is it for a perpendicular bisector.